Very good morning to all of you students. Welcome to the mathematics class. In this session, we will discuss the third part of the video of chapter 3 trigonometric function. This is related to the class 11th. Clear? Students, this is the most important chapter and the two previous videos are also most important and you have to see these videos again and again for solving the questions of this chapter. Clear? Now, student, in this lecture we will discuss trigonometrical equations and trigonometrical periodic functions. Clear? So first of all, I want to tell you what is the meaning of periodic function. So student, periodic function means if for each x and x plus k in the domain of a function f we have f x plus k equals to f of x. That means if we put the value of any variable in a function and after a fixed time of interval the value is repeated, then we can say that it is a periodic function. Means periodic means simply you can say that the repetition term. So f is called the periodic function of x and the least value of k is called the period of the function. Clear? In the same way you can write sine x plus 2 pi is equal to sine x plus 4 pi is equal to something that equals to sine x. So it means that all the values are equal and after some interval of time they becomes equal. That means we can say that these functions are periodic function. Clear? Now, student, the next term is trigonometric equations. The equations containing trigonometrical functions are known, angles are called trigonometrical equations. The same way as trigonometrical function, when we use trigonometrical ratios as a function, then we can say that these are the trigonometrical functions, and when the trigonometrical ratios are used as a equations in the form of equations, then we can say that they are trigonometrical equations. Clear? For example, sine theta is equal to 1 upon 2, cos phi is equal to 0, tan x is equal to under root 3. These are the example of trigonometrical equations. Clear? Okay students. Now we will discuss here general solution of the trigonometrical equation. If the equations are given like sine theta is equal to 0, cos theta is equal to 0, tan theta is equal to 0 and cot theta is equal to 0. In this case, the method of solving and the formula of solving the equations is like theta is equal to n pi and where n is belonging to integer. Clear? So this is the general solution of the equation in the form of sin theta equals to 0, tan theta equals to 0, cos theta equals to 0. Clear? Okay. Now when tan theta is equal to tan plus minus alpha, in this case we have theta is equal to n pi plus minus alpha where n belonging to integer. Student, there is a table in which some format of equation given and their solutions are also given. So if sin theta equals to 0, then theta is equal to n pi is the solution. If cos theta equal to 0 is given, then theta is equal to 2n plus 1 pi by 2 is the solution of the given equation. And in the case of tan theta equals to 0, theta equals to n pi, sin theta is equal to 1, then theta is equal to 2n pi plus pi by 2, cos theta equals to 0, then theta equals to 2n pi, sin theta equals to sin alpha, theta is equal to n pi plus minus 1 to power n into alpha, tan theta equals to tan alpha, theta equals to n pi plus alpha, cos theta equals to cos phi, theta is equal to 2n pi plus minus alpha. And the squares formula is also given, sin square theta is equal to sin square alpha, theta is equal to n pi plus minus alpha. Clear? Tan theta, cos square theta equals to cos square alpha and tan square theta is equal to tan square alpha have the same formula, theta is equal to n pi plus minus alpha. Clear? Now solve some examples. Find the principal solution of the equation sine x is equal to under root 3 by 2. So here sine pi by 3 is equal to under root 3 by 2. That means we can put here sine pi minus pi by 3 is equal to sine pi by 3 is equal to root 3 by 2. Therefore, the principal solution x is equal to pi by 3 or 2 pi by 3. Clear, students? Okay, now see another example. Solve cos x is equal to 1 upon 2. So cos x is equal to 1 upon 2, that means cos pi upon 3. Now we know that when cos theta is equal to cos alpha is given, then x is equal to 2 and pi plus minus alpha. Here alpha is pi by 3. Clear, students? Next example is find the solution of sine alpha is equal to minus root 3 upon 2. So sine x is equal to minus root 3 by 2 is equal to minus times of sine pi by 3, and it can be written sine pi plus pi by 3, that means sine 4 pi upon 3. So on equating we get x is equal to n pi plus minus 1 to power n into alpha, and here alpha is 4 pi upon 3. Clear, students? Now we will discuss some more examples. Now the first example is cosec theta is equal to 2 upon under root 3, and find the general solution of the following equation. So cosec theta is equal to 2 upon under root 3. So sin alpha will be root 3 upon 2 because it is a reciprocal of cosec alpha. Sin theta is equal to sin alpha. Here alpha is pi by 3. So we will use the formula theta is equal to n pi plus minus 1 to power n into alpha, that means pi by 3. Clear, students? So this is the required solution. Now student, the exercise 3G is very important, and generally one question is asked from this exercise, and the questions of this exercise is just depend on the standard formula and general formula. So by learning some standard formulas of trigonometrical equations, you can easily solve the questions of this exercise. Clear? This is your homework and you have to solve the questions of this exercise. Okay, students? So I think you all understand how can we solve the trigonometrical equation, because in the previous lecture you have to learn how can we solve the trigonometrical functions and how can we applying some important formulas like sum of formulas, difference of angles, product of angles. So I want to say only one thing, this chapter is very important and this chapter is very hard, because in this chapter you have to learn a number of formulas for getting more command. So student, keep watching the video and practice as much as possible for getting good knowledge about this chapter. Okay, student?